Good morning. We will start session 8 on chapter motion. So in previous session we completed the what you can say is in text numerical questions. So now in today's session what we will do is we'll solve the worked examples of these numerical questions, right? And then we will touch the exercise. I'll just give you the page number and the question number. Here the question number is given as like 8.1. Whatever it is written, I'll continue with it. So, or what we can do is we can go on writing it as question number 1, 2, 3. A continuous number we can give. That will be simple. But page numbers are ready. Page number 101, the first one. Questions you have to copy it. An object travels 16 meter in 4 seconds. So, and another object travels 16 meter in 2 seconds. This is a simple one. What is the average speed of the object? So, we can write here total distance traveled by the object is equal to 16 meter plus 16 meter. That is how much? 32 meter. And total time taken is equal to 4 seconds plus 2 seconds, that is equal to 6 seconds. What we have to find? Average speed. Average speed is equal to, we know the formula, total distance upon total time, right? Just substitute the values. So 32 divided by 6. So this will not get divided with a whole number. So 6 ones are 6, 5s are 30, 2 remainder, 6 3s are 18, 2 remainder, 6 3s are 18. So this continues. Meters per second is the answer. Fine. The simple one. We'll move to the next one, children. So now that is page number 102, second one. That is 8.2 actually. You will come to know it's all worked examples what I am solving. The odometer of a car reads, now what is the odometer? Odometer reads the distance travelled in the car, in the vehicle. Speedometer reads the speed. The odometer of a car reads 2000 km at the start of the trip and 2400 km at the end of the trip. So you can read that. Even you can see in your vehicle where you have some, nowadays we have digital odometers sometimes where it can just read, depends, right? Or else you can mark it. What distance it started, what distance it ended. If the trip took 8 hours, calculate the average speed of the car in kilometer per hour and meters per second both. So to find that, we should first of all know the distance travelled, right? So we'll write here now distance travelled by car, that is S is equal to ending was 2400 and the starting was 2000, that is equal to 400 kilometer. Time is how much? 8 hours. Average speed of the car is equal to distance by time. I can use this. So distance is 400 by time. So this will give you 50 kilometer per hour. Now I need to find the answer also in terms of meters per second. What we will do here is, don't do the whole calculation once again and convert that in meter, this in seconds, not required. Simple thing. Once again I will write this as average speed is equal to 50 into, how to convert kilometer per hour to meters per second, children? 5 by 18. So 2 9s are 2, 25s are. 25 5s are is 125 divided by 9. So I can say this as 9 ones are 9, 9 threes are 27, 9 nines are, that's enough. 9 fives, yeah, meters per second. We got the answer both in kilometer per hour and meters per second. Let's just check. I have just written the answer here, what they had given. So whether it is approximately or how. So 9 ones are 9, 10, 11, 12, 3 remainder. So 9 threes are 27. So I think that's enough. Approximately you can get this. That's fine. We'll go with the next one. Usha swims in a 90-meter long pool. She covers 180 meter in 1 minute by swimming from one end to another. So this is the swimming pool, children. So the distance is 90 meter. So she swims this way as well as this way. So she covers totally 180 meter in 1 minute by swimming from one end to another and back along the same straight path. Find the average speed and average velocity of Usha. So third one, total distance covered. Total distance covered by Usha is, I can say 90 plus 90, that is equal to 180 meter. Time taken by her is 1 minute, that is equal to 60 seconds. So this is about distance covered. Displacement will calculate in the second half. Now first one, what they have told, find the average speed and average velocity. To find the average speed we require distance. To find the average velocity we require the displacement. So we'll write here is average speed is equal to total distance divided by total time taken by her. So total distance is 180. Total time taken is not 1 minute. 1 minute is 60 seconds. Meters in terms of seconds, what we have to take. So 6 threes are 3 meters per second. This is average speed. Okay. Now this was the first part. Second part, what I will write here is total displacement in 60 seconds is equal to 0. Why? See, Usha started from this point, right? So this is A and this is B. If I talk about, this is 90 meter. She started here and again she ended at the same point. That means she ended at the initial point. What is the displacement at the same point if you end? It is 0. So average velocity. What is velocity? Rate of change of displacement. That is, rate is nothing but in terms of time. So displacement by time. So answer is 0.60. So be very careful. Sometimes in question, most of the children, what they do, they find distance. When in the question it is given separately as distance and displacement, you do calculate distance, but you forget displacement to calculate. So read exactly what they have given. Give the conclusion. Therefore, average speed of Usha is 3 meters per second and average velocity is 0. Right? We'll move to the next one. Page number 103, fourth one. Fourth one in the sense 8.4. Starting from stationary position, that is u is equal to 0. Rahul pedals his bicycle to attain a velocity of 6 meters per second in 30 seconds. It's not directly given here. Then he applies brakes such that velocity of the bicycle comes down to 4 meters per second in the next 5 seconds. This is first part of the question. Second part of the question, what they are telling here is, then he applies brake. Now, then he applies brake in the sense here, this is case 1. So, let us finish first the case 1 children. Here this part let us finish. Then we go calculate the acceleration of the bicycle in both the cases. Okay, let us just finish this. I'll just write the formulas there once again. A is equal to V minus U by T. S is equal to UT plus half AT square. V square is equal to U square plus 2AS. We'll finish the case 1. Direct formula. A is equal to V minus U by T. So A is equal to V is 6 minus 0 divided by 30. So A is equal to 6 by 30. A is equal to 1 by 5 meters per second square or 0.2 meters per second square. That is acceleration. Now case 2. What will happen in the case 2? Brakes are applied of the bicycle. It comes down to 4 meters per second. Brakes are applied means the bicycle is moving with what velocity here? 6 meters per second. Brakes are applied, that is why it comes down to 4 meters per second. Understood this? In next 5 seconds. Time is equal to 5 seconds. So calculate acceleration here. A is equal to, now what should be your acceleration here? It was moving. When brakes are applied, velocity reduced. So acceleration should be negative here. A is equal to V minus U by T. So V is how much? 4 minus 6 divided by 5. So minus 2 by 5. So acceleration is meters per second square or minus 0.4 meters per second square. Divide this, what you get. Therefore, you can give the conclusion. The acceleration of the bicycle in case 1 is 0.2 meters per second square and acceleration of the bicycle in second case is minus 0.4 meters per second square. Very clear, children? Okay. We'll move to the next one. So, the next question is on page number 108. Let's quickly solve them. Page number 108, fifth one. No, one second. What was my? Yeah, fifth one, correct. This was fourth one, right? So next is fifth one. A train starting from rest attains a velocity. A train starting from rest, u is equal to 0, attains a velocity 72 km per hour. So 72 into 5 by 18. So directly we can get it here. 2 9s are 2 3s are 2 6s are. So 9 1s are 9 4s are 20 meters per second. Okay. In 5 minutes, time is equal to 5 minutes. So that is 5 into 60. 6 5s are 30, 300 seconds. Assuming that acceleration is uniform, find the acceleration distance travelled by the train in attaining this velocity. That means you have to calculate A, you have to calculate S. To calculate A, do we have everything in the first formula? Applied. A is equal to V minus U by T. See children, sometimes I apply a formula. Sometimes there are two formulas which are applicable here. You can choose that, up to you. Okay. So V is 20 minus 0 divided by 300. So this is 20 by 300. So 0, 0, 1 by 15 meters per second square. Acceleration. You can keep that in fraction. S we want, shall we use this? V square is equal to U square plus 2AS. 20 square is equal to 0 square plus 2 into 1 by 15 into S. So this is 400 is equal to 2 by 15 S. S is equal to 400 into 15 divided by 2. 2 ones are 2 2s are 4, 0 0. 15 2s are is 30. 2 more zeros meter. So the distance travelled is 3000 meter. Now in the book they have given it as 3 kilometer, not required. That is, they haven't asked us to find the distance travelled in kilometer, they haven't asked. So you need not keep it. This is also absolutely fine. We'll move to the next one quickly. A car accelerates uniformly from two velocities are given. So that means first one is initial 18 kilometer per hour, that is 18 into 5 by 18, that is 5 meters per second, and V is 36 kilometer per hour. So this is 36 into 5 by 18, 18 ones are 18 twos are, so this is 10 meters per second. In 5 seconds, time is equal to 5 seconds. Calculate the acceleration. A is equal to question mark and distance covered by the car. Right? I know that question is anyhow given in the book only. You can as well see and write, but still I have written it with all the steps, what you have to write, what you have to find out. I hope I can give you this as a homework, children, as a practice sum. Okay? Where time is 5, A you have to find and S you have to find. So, which formula you want? Once again, A you have to find, they have not asked. Yeah, acceleration you have to find here. And the distance covered by the car in that time. Apply the formula and you find out. I know the answer and solution is there in the book, but rather I want you to solve it with given all these things. Because in the book they will never give you where is 5 by 18 there, right? So, sixth one I'll mark for homework. We'll go with the next one, and I think this is the last one of the work example. Yes. So after that we have an exercise. The last sum for today's session, 7th one. Brakes are applied to a car to produce an acceleration of 6 meters per second square in the opposite direction of the motion. This is very important. Brakes are applied in the opposite direction of the motion, minus opposite direction of motion. That's why I write here. If car takes 2 seconds to stop after the application of the brake, calculate the distance travelled by the car at this time. So, what we have to consider here now, we don't know what is U here, children. Why? Because we don't know whether the body was at rest, nothing is mentioned, or the body started moving with the velocity was not mentioned. We only know that brakes were applied. So, if brakes were applied, then V will become 0 here in this question, right? What we have to find? Calculate the distance travelled during this time. Now that means you have to find S. Two cases you can find S. These are the two formulas. But in both the formulas, to find S, you require U. So first we have to calculate U and then we can calculate S. So to calculate U, I think we can go with the first formula, that is A is equal to V minus U by T. A is minus 6 where V is 0. Minus U where time is T. So minus 12 is equal to minus U. u is equal to 12 meters per second. They have not asked to find u, but you understood why should we find? Because both the formulas may require u, otherwise you can't find it. Fine, take out the next one. You can even apply s is equal to, up to you. So v square is equal to u square plus 2as. So v is 0, u is 12 square plus 2 into a is minus 6 into s. 0 is equal to 144 minus 12s. Right? See, in the book they have used s is equal to ut. I have used this. Both will be having the same. Shift this side. Minus 144 is equal to minus 12s. Minus and minus will get cancelled. 144 divided by 12. 12 ones are 12 12s are. S is equal to 12 meter. Clear? That's a difference now. You can use even that formula and find the answer. This formula also and find the answer. So with that we complete worked examples of this chapter. Now we are only left with the exercise numericals which we will be completing in the tomorrow's session.